All right, guys, we're going to move on here to our next section. It's called exponents. And so this should be kind of some review of Algebra 2 trig. We'll kind of look at some of the more complicated issues that you dealt with for the first time in Algebra 2 trig last year. And so I wanted to start off, though, with these couple problems up here, numbers 1 and 2, because I often see people mess these up. And so number 1A and 1B, it kind of looks like similar questions here, but the answers here are 25 for this one, and the answer for part B is negative 25. Those are different questions, and they do have different answers in this case. Now, the reason why that is because of the parentheses, and so I think most people know on 1A actually is easier for most people, because you think of this like, okay, that's negative 5 times negative 5, and so we know that any negative times a negative is a positive, so that's going to give you a positive 25. However, part B is the one that actually people get more messed up on. I see people type this in the calculator sometimes and tell me, hey, Mr. Berry, this is supposed to be a positive 25, but the calculator said negative 25, and to which I respond, well, if you knew that answer, then why did you type it in the calculator, first of all? But second of all, the calculator is actually never wrong. The calculator is answering the question that you asked, and so if you ask it the wrong question, you're going to get the wrong answer. So what part B is saying is it's order of operations, and so this negative out front, I really think of that as like a negative 1 multiplier. This is saying negative 1 times 5 squared. That's how I think of it, is that negative is a multiplier. And so we know that if we have a multiplier, we have to do that after the exponents. And so the exponent is 5 squared, which is 25, and then we multiply that by a negative 1, which gives us a negative 25. So that's the key difference there, is an order of operations thing. So if it's just a negative there, you got to think of that as a multiplier, whereas if the negative is in the parentheses, we know that just means multiply this particular negative number by itself. I actually have another story on this. My sixth grade math teacher could not figure out why we had this question in the textbook, and my sixth grade teacher could not figure out why they were coming out different. She didn't have a good explanation, and I raised my hand because I was Mr. Berry even back then, and gave her the perfect explanation that I just gave you guys about order of operations, how that negative was really a multiplier, and she didn't really believe me. She said, well, I'm not sure about that. I'll have to ask my husband at home. And I was very mean when I was younger. I hope I've gotten a lot nicer since then. And I responded, well, maybe your husband should teach this class. She kicked me out of class right away. And I really feel bad about that even to this day. Although I would say that she was also wrong, because she kind of disregarded my perfect explanation, but I was also wrong as well, because I should not have been mean like that. And so it's one of those cases where both people were wrong. So I would really encourage you, even if you know that you're correct, that doesn't mean you have to be mean. That's a little life advice from Mr. Berry there. Okay, so moving on to question 2. So this one is going to be kind of similar. I know that the part A is going to be positive and part B is going to be negative. And anything to the 0 power is always 1. And so if I have negative 5 in parentheses to the 0 power, that is 1. It is not 0. It is always 1. Okay, so then just like we saw above for part B, this one is going to be negative 1 because that negative is kind of after the exponent. Okay, next up we're going to review our properties here. So we have kind of 5 properties we're going to talk about. So the first one here, we have a product property. So that's saying if we have two of the same bases multiplying, we actually add their exponent. And you can see the explanation there. That's 2 2's multiplying, that's 3 2's multiplying. So it's going to give us 5 2's multiplying. So that's our basic property there. Multiplying of the same base, we add their exponents. Now, this can also be written like this. We know that if we have 2 bases here, and they have parentheses in between them, that does mean multiply as well, so that would be the same thing. So 2 different ways that one could be written. Next up, we have the quotient property. So the quotient property is like bases kind of on top of each other. In that case, we subtract the exponents, and you can see the explanation here, because we would kind of cancel two of those out, and we left with 2 to the first. Okay, next up here, we have the power property. And so this one, we have 1 base with 2 exponents. I always like to kind of point that out here for the power property is 1 base with 2 exponents. And the reason I like to do that is I don't want you to get confused. I think a lot of people get confused this one with this one back here. And notice on this one we have one base with two exponents, whereas this one we have two separate bases that happen to be multiplying with parentheses. So I know both of them have parentheses, but they are different. So notice the difference between this one and that one. So this one we do multiply the exponents there, a times b, or in this case 2 times 3. And I think of it like this: 2 times 2, 2 times 2, 2 times 2. That's the 2 squared inside, and it's there 3 times. All right, next up we got negative exponents. Now negative exponents flip, okay? They don't create negative numbers, they flip a fraction. And so if you have a negative exponent on top, it moves down to the bottom and becomes positive. A negative exponent on bottom moves to the top and becomes positive. I was just kind of think about negative attituded people. A lot of times they're just in the wrong spot, so if you can just move them, a lot of times their attitude improves. Okay, now lastly here, and this one is going to be the one that's kind of new to you guys last year, and we'll review this one a lot. Very important here is fractional or rational exponents. Fraction and ratio mean the same thing, so a fractional and rational mean the same thing as well. And so anytime you have a fractional exponent, that is always referring to a root, okay? The base is the denominator, the denominator is the root, the numerator is the exponent. Now there's two different ways that you can write these. I'm going to tell you that out of these two, this one is going to be the more useful. They're both correct, but we're going to find this one is more useful than this one. So I'm going to circle that right there. And the reason why is that in this case, you're doing the root first and then the exponent. So your number is going to get your x in here, whatever that is going to get smaller before it gets bigger. Whereas on this one, although it would be equivalent, it's going to get bigger and then get smaller. So those numbers might get really big. But they are equivalent, and the thought behind that is because these are really, they're both exponents. A root is actually an exponent now that we understand that. And so there's no one that's higher than the other on the order of operations, since they're really just both exponents. Okay, so we see an example here, 27 to the 2/3 power. So you can see here that I did the third root of 27 and then squared. Once again, I could do 27 squared and then take the third root, but already you can see 27 squared will be a huge number, whereas 27, the third root, is 3. And then you square that and it turns into 9. All right, so we'll do some practice problems here. So first, we'll practice our fractional exponents. So the first one here, let's see, we got 8 to the 1/3 power. So remember, that does not mean that it's 1/3 times 8. It means it's the cube root of 8. Technically, it's the first power, if you want to think of it like that, but obviously that's not necessary. So the cube root of 8 is 2. 2 to the first power is obviously 2. All right, so the next up here, part B, we've got a little trickier. So on this one, the first thing I see is the negative exponent. I always like to move that first. So I'm going to make this 1 over 32 to the 2/5 power. Remember that a negative exponent does not create a negative number. It creates a fraction. So that gets flipped to the bottom. Now notice as well, I'm not flipping the 2/5. That's staying the same. I'm really flipping the base. The base is going down to the bottom. The 2/5 is staying as is. All right, so now I'm going to convert this into a a root. So it's the 5th root of 32, and then I have a squared there for the 2 in the numerator. The 5th root of 32 is the number that when multiplied by itself 5 times gives you 32. And you may not be sure of that, but if you test out 2, so we multiply 2 by itself, 2, 4, 8, 16, 32. On the 5th turn, it does turn into 32, so that's the number we're looking for. So we have 1 over 2 squared, so we have 1/4. All right, lastly here, part C. So for this one, I once again see we have negative exponents here, so I'm going to flip those. So it's going to become 64 to the 3 over 2 power, and then I have 25 to the 3 over 2 power. So actually I did a couple things there. So both of these had an exponent of 1, so I multiplied that in, and I also flipped it, and when I flipped it, the exponent becomes positive. So anytime we got a negative exponent, that's going to happen. All right, so we will do the square root of 64 to the 3rd power, and then the square root of 25 to the 3rd power. And so the square root of 64 we know is 8 to the 3rd power. And then this one will be 5 to the 3rd power. 5 to the 3rd power, I know off the top of my head is, see, 5 times 5 is 25. 25 times 5 is 125. And then 8 to the third power, I don't know. 8 times 8 is 64. 64 times 8, we'll go ahead and do some long multiplication here. That's all right, it's good for us. So we got 48, 5, 12. Sounds good. All right, next up here, we'll go through some more examples. So first of all, number 2, the first thing I see here is we got the coefficients, the big numbers out front. Those actually reduce like a fraction. They do not subtract because they're not exponents. Only the exponents are going to subtract. So I'll reduce those like a fraction. That's going to become 3 over 1. And now I'm going to move all my negative exponents next. So the s squared is going to stay up top because that's positive. And then the s to the negative 2 is going to move up top because that one was negative on bottom. Now it's positive up top. So we're only going to move the negative exponents. So then the t is going to move to the bottom and become positive 4. And then the t squared is going to stay there. Now, the next thing I always think about here is I think of like combining forces or a battle. So if your variables are on the same kind of level, top or bottom, they're going to combine forces. And so my s's are going to combine forces up there. So it's going to become s to the 4th. We're adding those together, which I'll try to draw a more neat 4 there. That's better. And then my t's as well are going to combine forces. So they're going to add and become 6. I'm not going to put the 1 down there because it's not really necessary. So I'll leave it off. Okay, so then next up here, number 3, we got a lot more going on, so let's go through that one. So first of all, we've got to take care of these parentheses, so I'm going to send these exponents in there. They're going to multiply by all the exponents. Now anything that does not have an exponent, I'm going to put a 1 there. And that's to remind me, hey, that negative 3 is not multiplying by 2. It's multiplying by 2's exponent. So that's going to become 2 to the negative 3rd power, x to the negative 6. So these are all multiplying now. And then y to the 9th on bottom, since negative 3 times negative 3 is positive 9. And we'll multiply that by, over here, we have x to the negative 10 on top. We have 3 to the negative 2 on bottom. And we have y to the negative 4 on bottom as well. All right, next up, I'm going to move all my negative exponents. I'm going to keep all my positive exponents put. So on this first one, everything's going to be on the bottom. So I'm going to throw a 1 up there. And we got 2 to the 3rd moving to the bottom, x to the 6th moving to the bottom, y to the 9th is staying on bottom because it was positive. Over here, actually everything's going to move, so I'm going to move 3 squared right there. I got to move y to the 4th up there, and then x to the 10th is going to move to the bottom. Okay, now I'm ready to, I might be ready to write my final answer here, we'll see. So the next step, first of all, I know 3 squared is really 9, and 2 to the 3rd power is 8, so I'll go ahead and write those down. So that's taking care of this and that. All right, so now the x's are on the same team. They're both on team denominator. And so I'm going to write the x there. They're going to combine forces in a 16. And then the y's are not on the same team. You can see we have y's on top and y's on bottom. So they are going to battle, okay? La guerra, the war. And so first of all, I like to look at who's going to win the war. So we can see that the bottom has 9 Y troops and the top has 4 Y troops. So that means that the bottom is going to win the war. So I'm going to go ahead and put the Y down there. And then how much does it win by? So if these 4 Y troops up top kill 9 of the Y troops on bottom, that's going to leave 5 Y troops on bottom right there. Now, for those of you who may have been thinking, hey, Mr. Berry, don't we subtract these? Don't we do 4 minus 9? And that's negative 5. That's technically correct. But if you think about that, if you do 4 minus 9 is negative 5, that actually means that we're talking about y to the negative 5 on top, which would mean we would want to move it to the bottom and make it y to the 5th as a positive on bottom anyway. So that's kind of how that logic works. I think if you just do the battle instead, and I'm pointing down there, so it's already there. So if you do the battle instead, it kind of tells you where those are going to end up. All right, next up here, number 4. So for this one, we're going to send this 2/3 power in there. Remember, it's going to multiply by the exponents, not the bases. So this will be 125 to the 2/3 power. And then this one will be x to the power of 6 times 2/3. So we're multiplying fractions now. So I'm not going to try to do that in my head. I'm going to go off to the side. I'm going to do 6 over 1 times 2 over 3. Anytime you're multiplying by fractions, don't be a hero. Go off to the side and show your work. Not for me, but do it for you. So remember, multiplying fractions, we do not need a common denominator. We are allowed to cross cancel, so that's going to be a 2. So that just comes out to x to the 4th, so that's not that bad. All right, so now the 125 to the 2/3 power, it is the cube root of 125 to the second power. And so we know that the cube root of 125 is 5, and then 5 squared is 25 times x to the 4th. All right, next up here, number 5. So this one, once again, I'm going to throw a 1 there. So it's going to multiply by all these exponents. So it'll be 4 to the 3/2 power. A to the power of, once again, 3/1 times 3/2. I'm going to do that math on the side. Nothing to cross cancel, so I'm just going to write that as 9/2. And then lastly here, I have 3/2 times 4/1. So I can cross cancel there, and that'll just give me b to the 6th power. All right, now I'm going to work with this number here. So it's the square root of 4 to the 3rd power. So that's 2 to the 3rd power, so that would be 8 times a to the 9/2 times b to the 6th. I'm going to leave my answer like that. If you were thinking, should we write this one as roots? I would say no on this case, because if you look at the original question, it was written as a fractional exponent. So I'm just going to leave it as a fractional exponent. All right, next up here, number 6. Now on this one, there's no exponent on the outside, so I'm not multiplying. I'm really adding here. Now, luckily, these already have a common denominator, so when I add them, I just keep that common denominator is going to be 9/5. Remember, with a common denominator fraction, we add the numerator and keep the denominator the same. And so I'm going to just leave the bottom for now, and now I'm actually going to be subtracting. I subtract the exponents down. It's going to give me my new exponent for a. And 9/5 minus 3/5 is 6/5. This one, because they already have the common denominator, I think is really easy to do in your head. A to the 6/5 power. All right, next up, number 7. So this one, I'm going to take care of this exponent first. I'm going to remind myself that 2 has a 1 there, so we're going to go 2 to the 3rd power, x to the power of 3/4 times 3/1. That's going to give me no cross-canceling available, 9/4. On bottom, 3/1 times 1/3 is just 1, so that's y to the 1st power. And then I'll go ahead and throw the 1 there, that's fine. And this one, I'm going to do that, and then I'm actually going to move the 1/2 up to the top here, just because it's a negative exponent. It's my only one, so I'll take care of that in this step as well. Okay, so now, what are we going to do next? Well, I have 2 to the 3rd power. I know that's going to turn into 8. My y's are going to battle. So I have 1 on bottom, 4 on top. Obviously, the top's going to win that battle. So I'm going to say y to the 3rd power. Okay, and then my x's. Okay, so my x's are on the same level, so they are going to combine. They're going to add together. So I'm going to have to do 9/4 plus 1/2. So this is adding fractions here. We need a common denominator. So that means I'm going to multiply this one by 2/2. And so it's going to give me 9/4 plus 2/2, and 2/4, excuse me. And that's going to give me 11/4. So that'll be my new exponent here, x to the 11/4 power. I have a 1 on bottom, which means I don't really need it, so I'm just going to leave my answer like that. All right, number 8 we're going to do in class together.